Hey everybody, welcome back to another video for quant reasoning. This video will cover sections 9A and B from our textbook, Unit A, 9A and 9B, at least the parts that we're interested in. And so anything that's not any topic that we skip in the video, you're not responsible for in those sections, okay? So I've combined these two. It'll be a little bit longer video, but it's also the last one for this term, so hopefully you'll get that out of it. So 9A, we're talking about functions, all right? And with functions, what we need to remember is that we've already had equations. Functions are just a slightly different way of writing the same idea, and it represents a specific type of relationship between two sets of objects, all right? So technically, a function describes how a dependent variable changes with respect to one or more independent variables. We're only going to have one independent variable. All right, so we're going to have an x and a y, and we rewrite the notation like this: y equals f of x. Or if before we would have had a linear function, y equals 3x plus 1, now we'll write f of x equals 3x plus 1 instead. All right, it means the same exact thing. Y is replaced by f of x, and the notation goes with it, and we'll talk about that notation, why it's handy, in a little while. Okay, so a couple of examples here. I'm riding in a hot air balloon. As the balloon rises, the atmospheric pressure decreases, right? When you go up in an airplane or something like that, your ears pop sometimes. So pressure is dependent upon the altitude. So we say P, pressure, is equal to a function of A, which is altitude. Okay, that's one way to represent that. You're going down a barge on a Mississippi River, and the width of the river changes as you go southward. So the further you go south, the river width changes. And so if D is the distance that we've traveled down south, and W is the river width. And so W, the river width, say that 5 times fast. The river width depends on how far down south you've gone, and so W is a function of the distance D. W is the dependent variable, and D is the independent variable. As we move south, the river width changes. All right, so we can write functions in 3 different ways. We can have a data table, all right? We can have a picture or a graph that represents the functions, or we can write an equation, and that's that f of x equals idea. Okay, that's a formula. All right, so let's take a look at a couple of examples here. First of all, we have a graph. Here's a graph. The graph of the function goes down, comes up, then comes back down. The input or the independent variable is x, and the output or the dependent variable is y, or f of x in this case. So when I say find f of 18, what that really means is what is y when x equals 18. That's what this f of 18, that's one of the reasons we write the function notation the way we do, because it's basically shorthand. It's much easier to say find f of 18 than it is to say what is y when x is equal to 18. Well, if we look down here, this is counting by 4, 8, 12, 16, 20, so 18's got to be right in the middle. All right, and then if we go all the way up here until we hit the curve, we're at this point right there, and that point has a 18 as my x value. What's the y value? The y value is 16. And so because of that, f of 18 is equal to 16. Okay, that's the way that works. All right. F of 18 is 16. So you guys take a look at that, and you guys pause the video and take a second and find f of 24. What does f of 24 equal? Okay, well, the same idea, 24, go up until you get to the point that you hit the curve. Oh, it's the same spot. F of 24 also equals 16, and that's possible, right? So that's how you do it if you've got a graph. How do we do it if we have a function? Example 2, if f of x is equal to 3 minus x squared, find f of negative 2. And so what I'm going to show you to do here, this is the best way to do it, all right? The best way to do this is to remember that the x is holding a blank spot. And so everywhere there's an x, you put parentheses around it or you leave a blank spot, and then we say, okay, we want to find f of minus 2. So if we want to find f of minus 2, then wherever there's a blank spot, we plug in a -2. And you notice that the parentheses are very important here because you do inside the parentheses first, which means we got to do this -2 squared. Before this negative affects that negative, we got to do -2 squared. And -2 times -2 is +4. And so we do 3 minus 4 and we get -1. Order of operations still has to occur. We do powers or exponents before we do subtraction. And -2 times -2 is +4. So we get 3 minus 4, and that's -1. And f of -2 is -1. And that's how we do it. Okay? A second thing about functions is the concept of the domain and range. The domain of a function is the set of values that the independent variable can take on, so what you're allowed to plug in. And the range is the stuff that you get out. It's the dependent variable. So domain goes with independent variable, which is our x's usually. Range goes with our dependent variable, which is y's usually. So if you're looking at the graph, again, same function we had here, and we're looking at the graph and it starts here and it goes over and stops, okay? Then the domain starts at 0, right? 0 here, and then as you go across, do you have any holes or any problems? No, not at all. It just goes up, down, and we get all the way over here to number 26. If we counted by 2's, that'd be 26, and so the domain is 0 less than or equal to x less than or equal to 26. Some books will teach you about interval notation, and interval notation we would write like that. Okay, I'm not going to expect you to do that, but you can write it either way. The range is a little bit trickier though, because the range is bottom to top. We don't read left to right, we read bottom to top. Well, what's the very lowest bottom value? And so down here we have 0 for y, that's the smallest y we ever get, the lowest down at the bottom. Okay, how far up do we go? Well, we go up here, we come back down. So this is our top point here, there's no holes or gaps. All right, so this is y equal to 20. So our range is 0 less than or equal to y less than or equal to 20, or 0 to 20, again using interval notation if you prefer that. Okay, either one of these is an acceptable way, but notice that this is an x for the domain, this is a y for the range because it's the dependent variable. Okay, so that's some basic function stuff. You guys should be relatively familiar with that from previous courses. We're moving into Unit 9b, which is linear modeling. We talked about linear equations in the last chapter. Now we're going to add to it a little bit and kind of think of them as linear functions now. And so a linear function has a constant rate of change and is a graph that's a straight line. So the first thing about our function is that all linear functions have a constant rate of change, and that rate of change is a slope. And so that's the change in the independent variable divided by the change of the dependent variable, or for most of us, we're used to seeing y2 minus y1 up top and x2 minus x1 on the bottom. If you have two points, right, is how you figure that out, and however you need to remember it is fine. Again, the exam on this will be open notes for you guys at least this semester, and so you'll be able to do that and whatever, but you should know m equals y2 minus y1 over x2 minus x1 anyway. So we often call the slope m in equations of the line. Okay, so if you've got 1 point here and 1 point there, the change of independent variable is how far you go over to the right and the left. That's the change in x, sometimes called delta x. Okay, from bottom to top, that's the change in y, sometimes called delta y. Okay, so there's all sorts of ways to represent it, but that's the basic idea. Okay, so algebraically, how do we write the equation of a line? We write y equals mx plus b. If you remember our equation before, we've already talked about this, right? M is the slope, right? What does that represent? Represents the rate of change. And b is the y-intercept on the graph, or what we were calling the initial value. What does that mean? That means it corresponds to when x is equal to 0. When x is equal to 0, mx goes away and you're just left with b, y equals b. And so that's why it's called the y-intercept on the graph, because it's where you cross the y-axis. And it's our initial value if you're given a description of the linear model. Okay, so for example, the equation y equals 4x minus 4 represents a straight line with a slope of 4 and a y-intercept of negative 4. So the y-intercept, once again, when x is equal to 0, y equals minus 4. So if you're trying to graph it, that's where you would plot that point. Okay, and here it is. And then in order to get from one point to the next, you have a slope of 4. And a slope of 4, if m is equal to 4, we think of that as 4 over 1. In other words, you go up 4 every time that you go right 1. Positive y is up, positive x is right. And so starting from this point, we go up 4, 1, 2, 3, 4, and we go over 1. Boom, there we go. All right, we go up 1, 2, 3, 4, we go over 1. There we go. All right. And so you see the balance here. It's constantly 4 to 1, 4 to 1, 4 to 1. That's what slope of 4 means. Okay. So you should be able to do a basic graph like that. All right. And you'll have some practice problems in the worksheets for you to practice on that. Obviously in my math lab, the graphing tool is a little bit weirder. So you're just going to be asked to recognize things in my math lab, but you will be expected on paper to do a graph of a straight line. And I'm looking for it like this. I do not want you to plot points. I want you to plot the y-intercept and then use the slope to get to the next point, just like we did. Okay. So in general, slope, if slope is equal to 0, then you have a horizontal line. If slope is positive, then your line is going up to the right. If your slope is negative, then you're going down to the right. So here the slope was positive 4. Notice that we're pretty steep and we're going up to the right. These should have arrows. All these lines should have arrows on the end to represent they go on forever. You should recognize that the sign of the slope means the direction that you're going. Okay. So if you're given a picture now and you want to try to figure out what the equation might be, all right, so what can we tell? We can tell right here that our y-intercept is 0. That's the point 0, 0. And so that's my b. b is equal to 0. That's easy to read off of there. How do we figure out what the slope is? Well, we figure out what's going on here and we try to make really nice, pick nice numbers. So let's pick this point right here, which appears to be 2 and then 1. So we go to the right 2 and we go up 1. If you're doing a slope for that, the change of y is 1. That goes on top. The change of x is a positive 2. That goes on the bottom. So the slope is 1/2. So what does our equation look like? The equation of our line would be y equals 1/2 x plus 0. Or we would probably not even bother with the 0. We would probably write y equals 1/2 x. And that describes this line. Okay. Now, use the equation to find the rain depth 4 hours after the storm began. Well, we should be able to read it right off of here, but just to be sure, if this is really our equation, 1/2 x, then how do we figure out what would happen after 4 hours? We plug in 4 for x, and we end up with 4 over 2, which is 2 inches. Okay. Notice that this is called inches over here, and so that's our unit for this particular example. Okay? All right. Finally, summarizing here, slope is change of y over change in x. The slope goes in here as a number value. The y-intercept is a number value. X and y are variables. And so if you see the slope and the y-intercept on a graph, you can create the equation. If you're given the equation, you can work backwards and get to the graph. Now, let's say we're given 2 pieces of data only. We're only given 2 points. We're not given a graph. We're not given anything else. We're just given 2 points. Well, we can find the slope because that's change in y over change in x. So y2 is 600. y1 is 0. x2 is 1960. Make sure if this is y2, then this is x2, that they go together. And then you subtract 1850. So m is equal to 600 over 110. And that reduces to 60 over 11. And we're just going to leave it like that. We could write it using, decimals, but then it would be rounded off, and I don't want to do that. So that's my slope. Okay, that's my slope. How do I find my y-intercept? Well, my y-intercept equals what when x is equal to 0? Well, I don't know. I don't know. So what I need to do is I need to come down here and I say, okay, y equals 60 over 11 x plus b. I don't know what that is. And then I use either one of these points, okay, either one of these points to determine what b has to be. So we use either one of these points and plug in for x and y and solve for b. So I'm going to use this one here. Okay, I get 600 for y. And I have 60 over 11 times x. X is 1960 plus b. This comes out to be kind of nasty, and so I wouldn't be this mean to you, but these don't reduce, and so 60 times 1960 is 117,600 over 11 plus b. So if I subtract that to the other side, I need to get 60 over 11, so I need to multiply the top and the bottom by 11, and that gives me 6,600 minus 11,600 all over 11 equals b. And so b is equal to 1,011 over 11 with a negative in front. Divide that by 11. Would not come out evenly, and so I got to leave it as a fraction. So my equation becomes y equals 60 over 11x minus 111,000 over 11. Again, I will give you things that work out much nicer than that, but the process is still the same. You find the slope first, and then you can plug in either point for x and y. It might have been easier to plug in 0, I suppose, in this case for y, but either way, you plug it in and you solve and you get what b is, and that is the process. All right, so as always, go check out my math lab, work the worksheets, and come ready to ask questions in Zoom class. We'll see you. Thanks.